Welcome back everyone. Today we are going to make sodium methoxide. For this you will need sodium metal and methanol. Before we start off with anything else, we are going to prepare a drying tube. Because I never did this preparation before, I decided to fill up a drying tube because I didn't know how long this reaction is going to take. The gases are able to vent without any humidity entering our reaction flask and destroying our product. As a desiccant, I decided to use anhydrous calcium chloride. Ordinary cotton is used to stop at the end of the drying tube to prevent any of the desiccant from freely flowing outside. Then I just added a bunch of methanol to 100 ml round bottom flask. The exact amount doesn't matter. If the sodium doesn't react fully with our methanol, we can just add more methanol. Then it was time to get some sodium. Using some pliers, I picked out a big chunk of sodium metal. Because I just wanted some sodium methoxide, I didn't need that much sodium. So I decided to cut down our sodium block. Using a knife, the sodium was cut. And you can see that sodium is a really soft metal. When sodium is freshly cut, for a short amount of time, you are able to see its metallic color. The chunk of sodium was then put onto a scale to calculate our yield. You can see that around 2.64 grams of sodium were used. For the sake of showing the reactivity of sodium metal, I decided to cut the metal block again. Here you can see its bright and shiny color, which quickly vanishes. After wiping the paraffin oil off the sodium, I just threw it into the methanol. Because the methanol was very cold and outside is also cold, I didn't use a reflux condenser or any sort of ice bath. If you decide to do this experiment yourself, please use an ice bath or a reflux condenser because the methanol will get hot and it will boil out of your flask. 5 hours later, the reaction was complete. For my applications of the sodium methoxide, it is okay if it stays in solution. Therefore, I didn't evaporate off excess methanol. We put the solution into a flask and labeled it correctly. And there we have it, a solution of sodium methoxide in methanol. By the way, the gas that is released during this reaction is hydrogen. And now for the yield, we used 2.65 grams of sodium, which corresponds to 0.115 moles of sodium. Therefore, we get 5.19 grams of sodium methoxide. I wanted to show why this component is dangerous. I dipped the pH strip into it and you can immediately see how basic this product is. I read somewhere that when you get some of it onto your finger, it won't hurt, but it will destroy your nerves in your finger and you will damage it. If you found today's video helpful, feel free to give me one of these and consider subscribing to my channel for more of this. I wish all of you a nice day. Until next time. Bye.